Hello. In this video, I'm going to explain problem 5 from the 2015 F equals MA contest. We are told that a 470-gram lead ball is launched at a 60-degree angle above the horizontal with an initial speed of 100 meters per second directly toward a target on a vertical cliff wall that is 150 meters away, as shown in the figure. And ignoring air friction, by what distance does the lead ball miss the target when it hits the cliff wall? So, one thing that we can immediately notice is that as this is a projectile motion and we're given the information such as like the initial speed of the ball, we can completely ignore the mass. So 470 grams does not matter at all. So one thing we can see is that this ball is being launched straight toward the target, and basically if there were no gravity it would hit the target, but because there is gravity it goes in a parabolic arc instead of a straight line and misses by some distance h, and that is what we want to find. So one thing that we see is that we want to find how far or how high the ball is when it's reached a certain horizontal position. So let's define horizontal position to be x, vertical position to be y, and the point of launch will be 0, 0. And we want to find y as a function of x. Now this is a very typical projectile motion problem. We're very used to finding y as a function of t and x as a function of t. But now we want to find y as a function of x, so let's do that. We can do that in general. So if we have a projectile launched at velocity v and angle theta above the horizontal, then we know that there's no acceleration in the x direction. And we know that the acceleration in the y direction is negative g, since upward is positive and gravity points downward. Then the velocity of x will just be the initial velocity in the x direction, which will be v cosine theta, and it won't change over time, so it'll just stay like this. The velocity in the y direction will be the initial velocity in the y direction minus the acceleration, or plus the acceleration times the time, and the acceleration is negative v, so we get minus gt. And now we can find the x position. It'll just be the constant velocity times the time. So we get v cosine theta t, and y will be just integrate this, or you can just use the standard kinematics equations. So it'll be v sine theta t minus 1/2 gt squared. Gt squared. So now, how do we compute y as a function of x? Well, that's very easy. Since x varies linearly as t, we just get t equals x over v cosine theta, and then we can just plug that into y. So we get y equals v sine theta times x over v cosine theta, so we get x tan theta minus, and then we'll get v squared cosine squared theta in the denominator, and then times x squared. So, and then we have this 1/2 g, so it'll be g over 2 v squared cosine squared theta, and then times x squared. Now if you look at this formula, let's do a quick sanity check. So one is that, notice this term x tan theta. Well, what is that? It's basically the linear term. And in fact, if you notice that if this particle were to continue in a straight line, as if there were no gravity, then indeed the height would just always satisfy y equals tan theta times x, just by the definition of the trigonometric formula, or the trigonometric function tan theta. And now, basically the second term, the quadratic term, tells you sort of how far short of that does the particle or does the projectile end up. So how far below this line does it end up being for at a particular position x, which makes sense because if you and let's see if this coefficient makes sense. Well, if you look at g in the numerator, that makes sense. If g were somehow higher, then we expect that the particle would be pulled down faster. And so it would fall, farther below that tangent theta times x line. And v is in the denominator, which also makes sense, because if the particle moved faster, then it would take less time to move a particular horizontal distance, and which means that it would fall less from that line in the given time. And as I mentioned, it is a parabola, and it's a downward opening parabola, and so those things make sense for the projectile motion. So now we can go back to this problem. in this case, what is x? Well, if this distance is d, and this distance is x, then x is just equal to d cosine theta. And really, if you look back here, the reason I brought up the fact about the particle moving in a straight line is that there were no gravity. Look at what this problem asks us. It asks us to find how, it doesn't ask us how high it is, but asks by what distance does the lead ball miss the target. And we see that the lead ball was initially aimed straight at the target, meaning that the line y equals tan theta x is in fact exactly this line going from the cannon to the target. And so we're basically, they're literally asking us for this second term, although with a positive sign. And so the distance by which lead ball misses target equals g over 2v squared cosine squared theta times x squared, and we know that x is d cosine theta, so cosine squared theta will cancel, and we'll get g over 2v squared times d squared. So gd squared over 2v squared. And if we plug everything in, doing it in SI units, you should be careful about this, make sure everything is in the right units. For example, if something was in centimeters instead of meters, you would have to be especially careful when plugging in the numbers. But in this case, everything is given in the standard meters and seconds. So we can do this. G is 10 meters per second squared by standard F equals ma convention. D is 150. So 150 squared over 2 times 100 squared, since V is 100 meters per second. And so 150 squared over 100 squared will be 1.5 squared, that's 2.25. And then times 10 over 2, so 10 over 2 is 5. And then times 2.25 is 11.25 meters. So we go back to our options. We see that the answer is 11 meters. And that's our answer. And now I want to show you one really nice way of seeing that the answer has to be this much. So one thing that you may notice is that basically this distance, 11.25 meters, is just the distance that an object would fall from rest. So like if we dropped an object from rest, then in 1.5 seconds it would indeed fall 11.25 meters just by 1/2 gt squared. And so is there some nice way of interpreting that? Well, indeed there is. If you look here, if you computed the amount of time for the projectile to reach the wall, it would end up being d cosine theta, which is the horizontal distance, divided by v cosine theta, which is the horizontal velocity, and that just ends up being d over v, which in this case is 1.5 seconds. And in fact, a really nice way to see this is so let's say we had that ball launched and it moves in a projectile, and I mentioned this straight line that the projectile would go on if there were no gravity. Imagine you had some object that traveled with the lead ball at the same horizontal velocity, but which was unaffected by gravity. And if you look in that reference frame, well, what does that object see? Well, this object sees, well, the ball does not move anywhere horizontally. Instead, because it's moving at the same horizontal velocity as the ball, and so in this frame, the ball will just drop vertically. And since initially the ball is launched with the object at the same horizontal and vertical velocity, it just drops from rest. Now when the ball hits the wall, this object will actually hit the target. Because the object is, again, will just be moving on that straight line that points straight at the target. And so basically, you can see that however far the ball will fall is really just a standard formula 1/2 gt squared, where t is the amount of time it takes for the ball to hit the wall. But now what is the time it takes for the ball to hit the wall? Well, if you look at the direction of that special object I mentioned, well, now this guy just travels in a straight line path. So it'll just travel 150 meters along this diagonal line, and it's launched at 100 meters per second. So it's just 1.5 seconds, as we had derived earlier. And so this is a really nice way of seeing that in the reference frame of an object that goes straight, unaffected by gravity, it just sees the ball drop vertically. And so you can just calculate the time it takes to reach the wall, and then just 1/2 gt squared. All right, thank you for watching, and I hope that was helpful.